We are now going to use the Constraints Manager, along with directives, to define net classes and design rules within the schematic. Note that the Constraint Manager requires Altium version 25 or later, as well as a professional or enterprise level license. The Constraint Manager offers the same spreadsheet-like interface from both the schematic and PCB editors. This integrated approach eases workflow and makes it quicker to access, easier to read, and simpler to apply across different designs. The Constraint Manager also supports the importing of directives from schematics. The Constraint Manager is available in a PCB design project only if the Constraint Management option was enabled in the Create Project dialog when the project was created. Note that if the Constraint Manager was enabled for the PCB project, the PCB Rule and Constraints Editor dialog is not available in the PCB editor. If the Constraints Manager was not enabled for the PCB project, only the previous approaches to define design constraints, use of design directives, and the PCB Rule and Constraints Editor dialog can be used. To open the Constraint Manager, ensure that a schematic document is open. Then go to Design and select Constraint Manager. Notice that there is currently only one clearance rule in this design. Click on the 10 mil in the cell that's at the intersection of the All Nets row and All Nets column. The Constraint Manager defines a clearance between objects in a row and a column. Notice that the PCB image showing clearances only appears at the bottom after clicking in a cell under the All Nets column. Now we can explore the 3 ways to add classes using the Constraint Manager. First, we can add specifically selected nets to a net class. This is the simplest method if we already know which nets we want to group together into a net class. First, let's click on the physical button in the top left corner of the Constraint Manager. Control-select the nets we want to add from the list. Then right-click and select Classes. Then Add Selected to Class. And then New Class. The Add Class dialog opens, where we can give the new class a name. In this case, Power. Click OK once finished, and notice that the new net class has been created and includes the selected nets. The next method to create a class will add a new class as a heading but will not have any members within that class. Right-click anywhere within the Constraint Manager's matrix area and select Classes. Then Add Class. We can create a net class, differential pair class, or an XNet class as shown. Any members of these classes will need to be added manually, which we will demonstrate shortly. Finally, we can use the Class Explorer, which is an easy and interactive dialog for creating and managing classes. Right-click anywhere within the Constraint Manager's matrix area and select Classes, then Class Explorer. The Object Class Explorer dialog will open. Click on the Power class under the Net classes on the left, and notice the nets under the Members column on the right. With the Power Net class still selected, right-click and select Add Class. Type SPI and press Enter. Click in the search bar under Non-Members. We can use this area to search for the nets we want to add to this class. For this project, the SPI nets are named in a way that include the SPI acronym in the net name, so we can search for our SPI nets by typing SPI in the search. Now we can select SPI MISO at the top and then shift-click SPI SCLK at the bottom to select all of the SPI nets. Click on the single arrow in the middle pointing to the right to add these nets as members to the SPI net class we've just created. Notice that these nets were moved from the Non-Members column on the left to the Members column on the right. Also notice that the Non-Members list on the left is now empty. This is because the SPI search filter is still active. Delete the SPI in the search bar to show all of the other nets again. Click OK to exit. Our new SPI net class, with all its members, are now listed in the Constraint Manager. Now let's set width rules for the net classes. Click in the cell under the Min Width column and in line with the Power Net class heading. Type 30 and press Enter. Notice that mil is automatically added, because we are currently using imperial units. Notice that the min width setting for the 3v3 and 5v nets have also changed to 30 mil. These are shown in gray, indicating inheritance from the power net class, shown in white. Also notice that the settings under the preferred width column automatically changed to 30 mil. This is because the preferred width must always be larger than or equal to the min width. Click in the cell under preferred width in the Constraint Manager table and type 50. Click the max width cell, type in 100, and press Enter. We may need to hover over the columns in the Values by Layers area to the right to refresh these values. To add a net to an existing net class, right-click on it and select Classes. Then, Add Selected to Class. Then, Power, as shown here with the ground net. Notice that ground is now listed under the Power Net class and has automatically inherited the same width rules as set previously. And a quick reminder to always save your work. The Constraint Manager does not dynamically save. Like other files, we must save manually to record our changes, in this case by pressing Ctrl+S on our keyboard. This saves these changes locally to our computer. We can still use directives in the schematic to define net classes and set up design rules. However, they are now imported into the Constraint Manager, rather than being transferred directly to the PCB. Double-click the power supply schematic from the Projects panel to open it. Press VF to zoom to the circuit and notice the red power net directives on all the power nets. Open the Constraint Manager again and click on the Refresh button at the top right to import the directives from the schematics. Click the Import button to import the Power Nets class with the 3v3, 5v, 12v, and ground nets. In the Constraint Manager, the Power Nets class with its nets are now listed. Notice in particular that the 5v and ground nets have inherited the width constraints set earlier for the Power Net class. Constraints can be saved as constraint sets and be reused later in the same design or even exported to use in another project. This saves time and can prevent errors. Right-click on the Power class and select Save as Constraint Set. Provide a suitable name to the new constraint set and click Create. Check that the constraint set shows up in line with the PowerNet class in the Constraint Manager. Right-click on the PowerNets Net class and click Select Constraint Set, then Power Set, to apply this new constraint set. Notice that all the design rules and constraints were copied from the Power class and applied to the Power Nets class. If we save the Constraint Manager again, we will see that we have warnings. If we hover the cursor over the warning sign, a pop-up will explain the warning. These warnings exist because we have nets that are part of more than one class, with different rules applied to each class. We can resolve this simply by removing the duplicates. Altium has brought its powerful CrossProbe feature into the Constraint Manager as well. Right-click on the PowerNets class and select CrossProbe. Altium will switch views and take you directly to where these nets are on the schematic. A few things to remember with respect to the CrossProbe feature. CrossProbe will switch to the first open schematic with those nets. If there aren't any open schematics that contain those nets, Altium will open all the schematics and switch to the first one with those selected nets. Jumping into the power supply schematic sheet, we can see the directives that used to be red are now blue. This shows us that these directives have already been imported into the Constraint Manager. Also remember that we can modify the CrossProbe display settings by changing them under Preferences, System, Navigation, Highlight Methods. This video introduced the Constraint Manager within Altium Designer and explored how to use some of its powerful features.